Question 1, Part B. Find the integral of sec² theta tan theta d theta. Looking at the integrand, we have a product of two functions where one function is the derivative of the other. If we differentiate tan theta with respect to theta, we get sec² theta. So we can integrate an expression in this form using an appropriate substitution. In this case, I'm going to let u equal tan theta, because when I differentiate tan theta, we get sec² theta. Now differentiating u with respect to theta, we get du d theta is equal to sec² theta, which happens to correspond to one of the terms in the integrand. Rearranging this equation here to isolate the differential du, we get du is equal to sec² theta d theta. Now from this line here, I can write the integral as the integral of tan theta sec² theta d theta. Since we're multiplying these two terms, I can swap them around using the commutative law. That just makes my explanation just a little bit easier. Now we can replace the sec² theta d theta, which is here, with the differential du. And tan theta can be replaced with the variable u. So the integral written in terms of u is the integral of u du. So integrating u with respect to u, we get half times u squared plus the constant of integration c. But the original integral is in terms of theta. Now we know that u is equal to tan theta, so we can substitute out the u and replace it with its equivalent in theta. Now u is equal to tan theta, so half times u squared plus the constant of integration c is equal to half times tan squared theta plus c.